Yeah, g'day YouTubers, Tinker O'Toole again with another video. Today we're going to talk about chainsaw angles for the dummies, if you will, especially if you've got a USG grinder or you're thinking about getting one, because the more you get into the angles on a USG grinder, the more confused that you'll get. So hopefully I can clear a lot of points up. But first of all, we'll talk about filing a chainsaw tooth, because the file was invented many years ago, long before the chainsaw grinder came out. People used to hand file them. Sure, they had commercial grinders, but people typically used to use the file out on the job. And if we look at a chainsaw tooth and we hold a file up against it, the whole idea is that you hold it parallel and you keep it 90 degrees so that it files the tooth uniformly. Now, when you put 10 degrees downward tilt and you lower the file, you'll find out that it stops filing at the back and stops filing at the front, because lowering the file down moves it away from the beveled angle that's on the top plate. So it reduces the top plate angle because it is not coming in contact with the back anymore. So it starts to file the front. And also by filing the front, it affects the side plate angle. So by 10 degrees downward tilt, it changes the angles of the geometry of the tooth. And this happens exactly when you're using a chainsaw grinder as well. So, and then what some companies do with chainsaw grinders, especially with the Stihl, they need, or they compensate for that. So in other words, if you set it to 30 degrees, you get 30 degrees. That's on the top plate, right? So that's on the top plate here. If you set the angle of the top plate cutting angle on the movable head, let's just say that you wanted 60 degrees on an Oregon, but 60 degrees on an Oregon, there's 30 degrees on here, then you'll get 30 degrees. But on some of the other grinders, you'll lose 2.5 degrees because 10 degrees downward tilt is going to change the geometry on the top plate cutting angle, as well as change the geometry on the top plate, unless you can compensate for that. Now, to compensate so that a grinder always grinds at the angle that you set it at, two things can set that off incorrectly. And that is the 10 degrees downward tilt, and we'll sort of get into that a little bit more. So by setting 10 degrees downward tilt, and if we look at a grinding wheel like this, there's the center line, there's your 10 degrees left and right. And if you're wondering what 10 degrees tilt on a file really looks like, if you've never used it before, if the center line is straight, that's 10 degrees there. So this is the reason, if you use 10 degrees downward tilt, you move away from the center line. So you're grinding out here off the center. So, and we'll sort of go over that and how that can help you grinding off the center line. So the 10 degrees tilt in a lot of cases will be your friend, because it's going to grind off the center line 10 degrees left and right. Now, the other thing that can cause offset grinding is as the grinding wheel wears down. Because as the grinding wheel wears down, you've got to pull this head down more. As you pull the head down more, it can become off-center. And if it becomes off-center, that means that it's going to grind a different angle on the left tooth than the right tooth. It'll no longer be symmetrical. So therefore, the way to compensate for all of this is offset angles. And we'll talk about those offset angles, especially for the Stihl USG grinder, because it has 3 different sets of offsets. And the whole idea behind that, like I mentioned earlier, that if you set this for 60 degrees top plate cutting angle, you get 60 degrees top plate cutting angle. If you set this for 30 degrees, you get 30 degrees. There's quite a few Oregon grinders, mainly the high-end ones, and the Tecomec, that have a offset of 2.5 degrees on the back scale and 2.5 degrees on the top plate scale. When using full chisel chains, you can offset that. We did a video the other day where when using a tiltable vise, the angles are different compared to a slidable vise. So it's interesting itself. So on a tiltable vise, you have to add 2.5 degrees, and on a slidable vise, you have to subtract 2.5 degrees, because one tilts away from the grinding wheel, and which is a tiltable vise, and a slidable vise just slides away from the grinding wheel. But the tiltable vise is the one that gives the more greater effect on the offset grinding. So we'll go over on the 3 offsets that are on the Stihl USG grinder and how they offset, and we'll just talk about that in general terms so that you've got a much better understanding of this particular type of grinder if you choose to buy one, or for that matter, if you choose to use one. So what we'll talk about now is offset grinding. And even if you look at the grinder, it's set at 0, but you'll notice that it tilts down on an angle. You'll see that the motor and the grinding wheel are not sitting, well, the motor's not sitting horizontal and the grinding wheel's not sitting vertical. It's 3 degrees off. The reason that they put 3 degrees off is because, irrespective of what angle that you set your grinder at, you want to make sure that the end result is that on the tooth, that if you set it at 60 degrees, it's going to be 60 degrees. If you set the top plate at 30 degrees, it should be 30 degrees. So with a normal grinder, this is okay if the grinding wheel stays the same size, but the grinding wheel reduces in size. This affects the offset of the grinding. What will happen if you don't compensate for it, it'll grind one tooth at a slightly different angle than the other tooth, and that can affect cutting performance. So how do you get around that? You guessed it, offset grinding. So what they do is that the head is set offset by 3 degrees. On the USG scale, which is on the back, the scale is just a protractor scale, and then there's just a little punch mark, and that's your indicator of where to set your degrees. So it's off by 3 degrees, but it's not a mistake. It's intentionally done on purpose, and we'll get to that in a minute. So you're 3 degrees off on the head. So it's giving you an additional 3 degrees because you're going to lose 3 degrees when you look at the B scale and the C scale. Now, the B scale, which is a sliding vise, why is it that you lose degrees on the B scale? Because the B scale has got minus 15 and positive 15. That's the normal setting for it on most teeth except for Hexa and for some of the rapid duro type chains. So you've got an offset of 3 degrees here. You've got an offset of minus and positive 15 on here. The C scale. The C scale grinds offset on the grinding wheel by 17 millimeters. And what I mean by that is the middle, and we've sort of gone over this before, and I'll just do it briefly again, that when you come right in and look down upon the scale, what I've got there is a little black line, and that's the actual pivot point. That's the point where this moves. And when you move it to 30 degrees, you can see that the tooth, because it's 17 millimeters, from the center line, it's offset. It moves across the face of the grinding wheel a considerable amount. So this really means that you're grinding up on the wheel like 10%, which is like that. You're offset grinding. I've measured it before and it's round about 10-degree tilt, right? It's offset grinding. So the combination of this, the combination of minus 15, positive 15, and 3 degrees offset on the head means that you're going to end up with the correct geometry. If you set this to 60 degrees, you get 60 degrees. If you set that to 30 degrees, you get 30 degrees. There's many things about the USG grinder that are totally different than an Oregon style grinder. Now, in one of the videos I showed you the Jolly Star, and the Jolly Star has an offset of 2.5 degrees on here for full chisel, and it has an offset on here of 2.5 degrees. But we've got 3 degrees permanent offset on here, all right? And if you look at the Oregon 520, it's got marks exactly for the same thing, for offset grinding. Not all grinders have it. Mainly the higher end ones have it. The Oregon 520 is a very upmarket grinder. It has a slidable vise and it has a tiltable vise. The slidable vise is to make sure that the grinding wheel is grinding in the middle. Now, I mentioned before that if you weren't grinding in the middle of the grinder, that if you had 10 degrees to the left and 10 degrees to the right, it means that you're offset grinding. If your wheel is 1 millimeter off center, it means that it's grinding different to the left and it's grinding different to the right. And that's why what Stihl do is give you permanent offset. And by having a permanent offset, it balances everything out even when the wheel reduces in size. If 10 degrees downward tilt didn't change the geometry, then you wouldn't need the offsets. You could set the grinder up, and if the wheel didn't get smaller, then you wouldn't have the offset problem as well. If you were to use a diamond wheel or a CBN wheel, then the offsets would be different again, but they don't mention that at all. So what the manufacturers do, they just turn around and sometimes build a bit of an offset into the grinder and you don't even know about it. And this is exactly the case with this type of grinder. There is another offset on this grinder, and I'm still yet to figure it out as to why they did it. I don't know. German engineers. Look, German engineers are brilliant engineers. They even used to, build a lot of the parts for the space shuttle and the Apollo missions and everything else. They are brilliant at engineering. So there is a reason why they made all these offsets on the grinder, and the main reason is if you set it up to do 60 degrees or do 30 degrees on here, that's what you're going to get even as the wheel wears down. So I'll show you the other offset, and it's an interesting one. Okay, so we're looking at the back of the grinder, and if we zoom in and look up at the top, I've got a digital angle gauge on there. We're sitting at 0. But when we have a look here, can you see the difference between the left-hand side and the right-hand side? And even if we go back a little bit more, the bolt location, these are eye sockets, right? They look like an eyeball. And they're 12mm bolts, I think they're 12s. And they look like a bit of an eye socket, and you tighten them up on either side and it eliminates all side movement. But if I pull the arm down, you can clearly see that one side, and we just sit that on there, so even this has got 0.2 degrees on it, right? So this thing, the head is sitting very accurate. It's dead flat. There's no question about that. Even if we have a look here, I'll see if we can zoom in and see. I've set the angle gauge over here on the base, and it's saying 0.2 of a degree. So this part is close enough to dead flat. But for some reason, and I still can't figure out why they did it, have a look at the angle here. There's more of a gap in here than there is here, and this typically is tilted on an angle. And you can see the height of the bolt to the top here to the height to the top of the bolt there. It's much larger on this side by a few millimeters. So for some reason, they've put this at an angle tilting downwards. So that's level there, but they've tilted it on an angle. Now, it's not because it's 3 degrees downward tilt or anything else like that there. They must just feel that it actually works better at an angle for some reason. So I've got no idea, and I can't figure out why they've designed it like that, because there's no reason to put this on an angle that I can see. But nonetheless, they've done it that way for some reason. And I guess the only person that could probably answer that will be Stihl, and I don't think I've got any chance of them letting us know why it's done that way, unless there's somebody that used to work at Stihl and actually knows why that is offset. It's got nothing to do with the offset of the 3 degrees, because as I said before, the A scale, which is, you've got a scale here, there's the A scale there, right? There's your scale from minus 15 degrees right up to 50 degrees. And all you've got to do is put a reference mark, which is stamped on the back of the plate. You stamp it with you punch a mark on there, and that's your reference point. So the 3 degrees being offset on this grinder was intentionally put there because when you do 10 degrees downward tilt, you lose 2.5 degrees on an Oregon grinder, but you lose close enough to 3 degrees on here. On each grinder, it could be slightly different. It could be 2.7 on one grinder. It could be 2.8 on another grinder. Here, on this particular grinder that I've got, it's close enough to 3 degrees, so I call it 3 degrees offset. So it doesn't matter if it's offset. What matters is that, as I'd mentioned before, that if you give it 60 degree angle, that you get 60 degree on the top plate cutting angle. And if you give it 30 degrees on the top plate, that you get that. Because on all grinders, especially the grinding wheel, reduces in size, you're going to offset grind. So if you're going to offset grind, then by giving 10 degrees downward tilt will ensure that the left side and the right side are ground evenly. And this is another argument that you hear people turn around and talk about the 10 degrees downward tilt. And they say, oh, look, I don't do the 10 degrees downward tilt. I can't notice any difference. I used to say that myself before I fully understood what 10 degrees downward tilt does. 10 degrees downward tilt does two things. It changes it does more than two things. It changes the geometry of the top plate and the top plate cutting angle, and it also changes the side plate angle as well. It reduces the beak or the hook, if there is any hook. The whole idea is that you don't get hook in the first place. But by moving the grinding wheel away from the center line when it grinds a tooth, it has that effect on the geometry. It changes it. So the tiltable vise, when you put this in the 10-degree tilt option, and that's just a matter of, for a right-hand tooth, pushing that away from you. Now we're in 10-degree downward tilt. This will reduce the angle by 25 degrees because it'll grind the front of the tooth first, just like the file does. So in other words, if we put it on 30 degrees, we're going to end up with 27.5. So it's just a matter of advancing this to 32.5, which means you're going to lose 2.5, it'll bring it back to 30. If you leave it on 30 degrees, you're going to end up with 27.5. So when we go to a slidable vise, like this Jolly Evo on here, and we'll just zoom in there so that you can see it, this goes from 15 degrees to the left, 15 degrees to the right. So to put 10 degrees downward tilt on these type of grinders, it's just a matter of sliding it to the 10-degree position. The tooth will start to grind at the back. By grinding at the back, you're going to increase the angle by about 2.5 degrees. So in other words, if you've got it set at 30 degrees, you're going to end up at 32.5. So if you set it at 27.5 and it increases by 2.5, you're going to end up back at 30. That's the way these two grinders work. And as I mentioned earlier before, on the Jolly Star, it's got settings and notches built into the grinder. The high-end grinders have usually got notches on there so that you can put that 2.5 degrees, add that on. And that's the same as the Oregon 520. It's got the 2.5 degree notches added to it so that you can adjust for that. On the Stihl USG grinder, it's all built in. You don't even have to worry about 10 degrees downward tilt. So I hope that explains the difference between a tiltable vise, what you can lose, the difference between offset grinding between a tiltable vise and a slidable vise. A lot of people don't know that, but that's what it does. Okay, so this is really going to illustrate what I was saying before about grinding off the centre line. Now the centre line here, you see where that arrow is, but you can also see where the bolt is, that we're off the centre line in the upper position. We have to bring that grinding wheel down approximately about 70 millimeters. As we travel down 70 millimeters, you'll find out that the arm is going to move in a circle, in an arc. So therefore, what will happen, this bolt will get closer to the ruler. And that's what we refer to offset grinding. We don't want to offset grind, but we've got no choice as the wheel reduces in size. So as we pull this down, you can see the bolt starting to come into the middle of the ruler, and by the time we get into the grinding position, we're dead smack into the, depends on how I move the camera, but that's about perfectly in the middle on that angle there, right? But as you can see, going up, and if we go up 10 millimeters or even 5, it goes off center. You can see that? So if we were to continue going down, you're going to find out that it's going to move to the other side. The same way as that when we lift it up, it moves to the other side. So it starts off being further away from the ruler, getting close to the ruler. As we go down further and further, if we could keep going down, it's going to go back that way again. So the whole idea, what the manufacturer does, is that when they set the grinder up in the grinding position like that, they make sure that the vise is roughly in the middle of that bolt. That's what they do. And that's why we refer to offset grinding. So depends which way you look. So the whole idea is if you line the ruler right up correctly, you're right in the middle of the bolt now, right? So we zoom in there, you'll see that real good. But you can see as we move up that it moves away. There's probably about the perfect spot, but it moves down a little bit. We're a little bit off center, not much, maybe 0.5 millimeter. It's not a lot, right? And the thing is, if you look at the difference and we move up an inch, you can see it's only about 2 millimeters in an inch. So it's just a little bit. And that's what I refer to offset grinding, and that's totally unavoidable. But if you have 10 degrees downward tilt, and we'll demonstrate that in the grinding position. So what do you think's going to happen when I tilt this vise 10 degrees? And we'll tilt this 10 degrees. Have a look at that. Look how far that moves off the center line. Now, and when we tilt it to the other direction, it does the same thing. It tilts away. So you can see now that if you're only 1 millimeter out, it's not really going to have a huge effect when you're 10 millimeters off the center line left and right. But when you don't have tilt and it lines up in the middle like that, right, that's lined up dead smack in the middle right now, right, then if I go 1 millimeter to this side or 1 millimeter to that side, it has a much bigger effect and more error that's on the tooth. Whereas 10 degrees downward tilt moves it a considerable away from the center line on both sides, and you eliminate a lot of errors. It won't have much of effect on the geometry when you're using 10 degrees downward tilt. And on the Stihl USG grinder, it's set up in such a way that you're offset on those 3 angles, the A scale, the B scale sliding vise, and the C scale, which is for the top plate. It's all offset. Every angle is offset to give you the same angle as what you set up. So I hope that information helps. It's just interesting when you look at offset grinding and how it can affect. So especially the beginners out there, if you're watching this, you'll have a much better understanding about offset grinding away from the center line. Pretty straightforward stuff. Anyway, thanks for watching. Bye for now.